Welcome to homework.
We're asked to find the values of Ackermann's function. So in part A, we're asked to find a of 2, 3. So to find a of 2, 3, first recognize that we have m is going to be 2, which is greater than or equal to 1. And we have n is 3, which is greater than or equal to 2. So that by the recursive definition, this is the same as a of 2 minus 1 is 1. A of 2 and 3 minus 1 is 2. And so what is a of 2, 2? Well, we have m is equal to 2, which is greater than or equal to 1, and n is equal to 2, which is also greater than or equal to 2. And recall that since, if we're looking at it as n and m this way, we have n is equal to 1. Or I guess you could say, instead of m here, it should be m is equal to 1, and n is just some number which is going to be greater than or equal to 1. And so by a previous exercise, we have this as 2 to the n, which is a of 2, 2. It's a nice shortcut for us. And this is equal to, again by the recursive definition, 2 to the a of 1, a of 2, 2 minus 1 is 1. So now we have a of 2, 1. This one's actually pretty easy. So m is 2, which is greater than or equal to 1. We have n is equal to 1. And so this is going to be 2. This is going to be equal to 2 to the a of 1, 2. And now we have that m is equal to 1, which is greater than or equal to 1. And the n is equal to 2, which is greater than or equal to 2. And again, we have, if we treat this as m and n, we have that m is equal to 1 and n is greater than or equal to 1. So it follows that by previous exercise, this is the same as 2 to the 2 to the n, which is 2. So 2 to the 2 squared, which is the same as 2 to the 4th, which is the same as 16. That's our answer for part A. In part B, we're asked to find the value of a of 3, 3. And to do this, well, by the recursive definition, we have this is going to be a of 2, a of 3, 2. And using the recursive definition again, this is a of 2, a of 2, a of 3, 1. And we know what a of 3, 1 is. Since n is equal to 1, this is simply going to be a of 2, a of 2, and then this is just 2. And we have, from the previous part, well, before we do that, we have again by recursive definition, this is a of 2, and then a of 1, a of 2, 1. And again, we have that in this last a, we see this as m and n, we have that n is equal to 1. And so this is just going to be equal to 2. So this reduces to a of 2, A, 1, 2. And now, notice that we treat this as m and n again. We have that m is equal to 1 and n is greater than or equal to 1. So by a previous exercise, this is the same as a of 2, and then this is going to be 2 to the n, which is 2, so 2 squared, which is the same as a of 2, 4. And by the recursive definition, this is the same as a of 1, a of 2, 3. And recall from part A, we found that a of 2, 3 was 16. So this is going to be equal to a of 1, 16. And again, if we treat this as m and n, we see that m is equal to 1 and n is greater than or equal to 1. And so by previous exercise, we have that this is equal to 2 to the n, which is 16 in this case, which is quite a large number. So I'm just going to write it out instead of calculating. This is 65,536.